Hey class, today we're going to look at our last lesson for our data analysis chapter for our stats unit, which is comparing distributions. So in the last lesson, if you haven't watched it yet, you're going to want to go back. We talked about how to describe a distribution using the SCSU, shape, center, spread, and unusual features. Today we're going to look at those same items, but we're going to use them a little differently when we're comparing two distributions. So we'll just start reading here. It's always more interesting to compare groups. Three most important things you need to properly compare the SCSU characteristics of a quantitative distribution are use comparative language, and use comparative language. And we say that because it's so easy to just try to describe the distributions, but we're not describing when we're comparing. We have to use comparative language such as more than, less than, same. You don't actually have to state the values. I don't have to say what the median is or what the IQR is or anything like that. I just have to say which ones are higher or lower or the same. All right, so let's look at our first example. We have two histograms. Summarize the length in minutes of movies nominated for Best Picture in 1980s and then in 2000 to 2006. I wanted you to see a little note here. We have to make sure that the horizontal axes are scaled the same for both distributions. If they're not scaled the same, it can be misleading, especially when you're creating your own histograms or graphs. When you're comparing things, always make sure to scale that horizontal axis the same. All right, so we're going to start with shape. The distribution for the movie length in minutes for Best Picture nominations is, and we're going to look at the 1980s versus, so if we look at the 1980s versus the 2006, the 1980s is going to be more skewed right. So more skewed right than in 2000 to 2006 movies. So notice I didn't have to say anything about the 2006 movies being symmetric. It doesn't actually matter what that one is. All I care about is comparing them. And that comparative word here, more skewed, is super important. If you just said skewed right, you wouldn't get any credit for that. Just simply stating facts is not comparing, even though it seems like it should be, it's not. All right, so there's shape. Let's look at the center. So here, I don't have any of my data values, which means I can't find the mean or the median. So all I can really say is that the typical movie length in 2000 to 2006 is, and if you look at this peak versus kind of this peak here, you can see that it's slightly higher, not a whole lot higher. So I'm going to write slightly higher than in the 1980 movies. So we've got shape and center. And again, that comparative word is the higher piece there. So the movie length distribution is, and now here we're supposed to be talking about spread, but because we don't have the data values, we can't talk about the standard deviation or the IQR. So what we're going to just say is which one is more spread out than the other. And if we look at the 2000 to 2006 movies, they're definitely more spread out than the other one. So I'm just going to write more spread out. And again, that more piece of it is that important comparable word. All right, and then the very last piece, unusual features. So is there any like possible outliers or something? Again, we don't have the data values to calculate whether there are outliers, but we can kind of see like there's some pieces over here that don't really fit with the rest of the data. There's one piece over here that doesn't really fit. This has four different movies that are in that section. This is only one. So we can say something like there are more potential outliers. We don't want to say outliers because we're not sure. We haven't done the calculations to figure out if they are outliers or not, but we can say more potential outliers. And again, I'm going to circle that word more. It's super important that we have that comparable word. All right, to our next example. So now we do have some data values. So we can do a little bit more with this. So compare back-to-back STEM plots that summarize the numbers of hours 23 boys and 15 girls spent playing video games. So the first thing we want to do, because we're going to want to talk about the shape, center, spread. So the center and spread, we want to use the median and the IQR. Now, granted, we could plug these into a calculator, find the mean and the standard deviation, but the median and the IQR are kind of easier to deal with, so we're just going to use those. So the first thing you want to do is, if I have 23 boys, then the 1 plus 23 divided by 2, the 12th value is going to be my median. So I've already kind of circled that here. That's this piece here is the median. So that's the number 42 for the boys. The Q1 is 34. It's the median of the lower half. And the Q3 is 59, the median of the upper half. So my IQR is Q3, which is 59, minus Q1, which is 34. So I get 25 for my IQR. And then for the girls, similarly, our median is 36. Oops, my pen is lagging here. My Q1 is 28. And my Q3 is 44. My IQR is 44 minus 28, which ends up being 16. Oops, 16. So now that I have those pieces calculated quickly, I can write a little bit more of a accurate description between the two of them, a comparison. So the distribution for number of hours spent playing video games, we always want to put that context in there. And we're going to do shape. So shape, if you look, they're both pretty symmetric. But if you look at the girls is perfectly symmetric, which is beautiful. So I'm going to say that it's more symmetric. Sorry, my pen is lagging here. Looks horrible. So more symmetric for girls than boys. And then because for the center, I have the values, I'm going to use the median number of hours playing is, and just look at the medians, it's going to be higher for the boys than for the girls. The IQR for spread, IQR, sorry again about my pen. So the IQR is also higher for the boys. All right, and then neither distributions have any outliers. So they're both symmetric. There's nothing crazy. You can actually calculate those outliers just to be sure. I've already done the calculations and there are no outliers between those two distributions. All right, last example here. We have 3 box plots to compare. And box plots are a little more difficult sometimes to talk about shape, especially, so we'll chat about that for a sec. All right, the distribution of egg length of robins is, and so if you look at the shape, the robins are really symmetric, but the wrens are a little skewed. It's hard to tell which direction. The hedge sparrows, again, has that outlier and it's a little skewed. So I'm just going to say that the robin is more symmetric than for the hedge sparrow and the wren. So that takes care of that comparison between the shapes. And again, I have the median because it's a box plot. So I'm going to say the median egg length is, and it looks like the hedge sparrow has the highest, so it's highest for the hedge sparrow and lowest for the wren. So it's nice to have both of those so that you know not only that the hedge sparrow is the highest, but also where the robin and the wren compare to each other. And then, so we've got shape, we have center. So now we want the spread. So the IQR. And if you look at the IQR is the section between this and this, that's your IQR. And if we look at all those sections, they're actually about the same. So the IQR is about the same for each bird species. And then the hedge sparrow is the only species with an outlier. So that kind of describes not only that it has an outlier, but that the other ones do not. All right, and then the last little piece here, explain why comparative analysis is inappropriate for this display. So we have types of sports, favorite sports between girls and boys, and unfortunately we can't do a comparative analysis because these variables are categorical and not quantitative or numerical. You can only do just comparative analysis for numerical data.